Hey guys, guess what? You made it to lesson 100! Yeah, it's pretty weak. I actually looked around for a little party hat, because I thought, oh, that'd be so fun. We should celebrate, which usually this is a big deal when we're together, okay? All I could find was this little train whistle, which I actually thought was kind of cool though, because we could say that you guys have been chugging along and you've powered through in this whole course really, but especially in these last couple weeks when things got challenging. So hats off to you. All right, so we're gonna dive in, and what a lesson to do as your 100th lesson, because this is not hard. Don't hear me say that. It's not hard. It is one of those concepts though that I repeatedly over and over again have seen give students trouble. The reason it gives you trouble is because if you don't remember the process and the rules, the signs can get confusing, okay? So that's why I want you to pay really close attention to the way that I explain it today, okay? And if you need to, go back and watch it again, okay? And you'll notice that once we are back together, or even if for some reason, we're not back together real soon and we keep doing warm-ups together on video chat or whatever, you'll notice that when we do these questions as practice in class, I always ask the same questions over and over again, which we're gonna talk about today, okay? So just follow along. Don't be worried. It's really not a hard concept. It's just easy to get it mixed up. So I want you guys to focus and do your very best. I know you can, okay? So we're talking about algebraic addition of integers. So let's review what integers are really quick. Integers are gonna be any positive or negative number. So if you think about a number line and you've got 0 right here, and then going to the right, you've got all these positive numbers, okay? Which these are considered whole numbers, okay? Integers are whole numbers and their opposites. So that means and the negative versions of those numbers, okay? So integers cover each of these individual values. So we're just talking about the individual values, not the little spaces in between them, okay? That's gonna be for later, but today we're just talking about integers. So when we talk about adding integers, we're talking about combining any of these numbers. So that could mean we are adding two positive numbers. It could mean we're adding two negative numbers. It could mean we're adding a positive number and a negative number, okay? So it can get a little tricky if you are looking at the signs and you start to get overwhelmed or confused as to what you're doing. So we're gonna start with a real life application so that it makes more sense and you can kind of put it in a frame of mind that can be something that you can associate with it. But then we're going to look at some rules, some hard and fast rules that will work no matter what every time, okay? The best way that I actually like that the book uses this, so the best way that I've always used too to explain this is using temperature. All right, sorry, I hope that this split doesn't mess it up. I had to cut something because I drew it wrong. So anyway, we're going to start with temperature. We're going to start by doing, measuring the temperature from, thinking about outside temperatures. Okay. So if you think about starting at a temperature of, let's see, where did they start? Okay. So if we start at a temperature of 0 degrees, which is really, really cold. So we start at a temperature of 0 degrees, which never happens here. Okay. So start at 0, and then we have a temperature drop of 5 degrees. So that's going to go down 5 degrees, which means we're technically adding a negative 5 degrees, okay? So that means that 0 plus negative 5 is going to put us at negative 5, okay? So now we're at negative 5. That's not too hard to understand. But then if we have another drop of 5 degrees, okay, so we're dropping 5 more degrees. So that means now we're adding another negative 5 degrees, okay? So now we've got negative 5 plus negative 5. Well, we can see here by the way that we just drew that puts us at negative 10. Well, if you look at the numbers themselves, 5 plus 5 is 10. So when we are already at negative, a negative value, and we add another negative value, we're just making our answer more negative. We're just adding the amounts and making our answer more negative, okay? So that is the foundation for what we're gonna look at. Now, if we are at negative 5 degrees, okay, and we see a rise in temperature, we see the temperature go up 5 degrees, then that will take us back up to 0. So there we see that when the signs are different, when we have a negative being combined with a positive, we are actually subtracting the values because 5 minus 5 is 0. Okay, so from those two concepts is where we get our rules. There's two main rules that I want you to remember, okay? If the signs are the same, so same signs, you add and keep the sign. Different signs, you subtract. I know this is lots of writing. Writing is boring. I'm sorry, but these are really important. So that's why I'm like writing the whole thing. You subtract and take the sign of the bigger number. So now, it doesn't necessarily say these rules in exactly those words. It kind of says something similar in the book, but it doesn't say it just like that. So if you want to pause here for a second and write these down, that would be a great idea because this is how I teach integer addition. So go ahead and pause and write this down real quick. If you want to do that, when you're ready, you can just jump back in. Okay, so we're going to move on. So same signs you add and keep the sign, different signs you subtract the values and take the sign of the bigger number. These are the rules for addition, okay? So we're gonna start by just looking at some addition problems and how we can apply those rules. So let's look at the first example, which is gonna be to add positive 8 and negative 5. Okay, so now my question to you would always be, are we looking at the same signs or different? And you would say, well, this one's positive and this one's negative, so those are different signs. And I would say, good job. So different signs means you subtract and you take the sign of the bigger number. So we're gonna subtract 8 and 5. Don't worry about the signs. You just think subtract. I'm subtracting 8 and 5, which will give me 3. Now you think about the sign because now you say, okay, I subtracted, and when I subtract, that means I take the sign of the bigger number. So what's bigger, 5 or 8? Got it, 8 is bigger. And we see that the 8 is positive. So this is gonna be a positive 3, okay? I know you're with me. I know you guys are doing great. We're gonna keep going. So let's look at the next one. We wanna add negative 5 plus negative 3. So this time, same question. Same signs are different. Well, negative 5 and negative 3 are both negative. So we would say those are the same signs. So when they are the same signs, remember that just means we're getting more negative. So you add the values. 5 plus 3 gives you 8. Now we think about the sign. So when they're the same, we add the numbers and we keep the sign. So if they were both negative to start with, our answer is also going to be negative. So we end up with a negative 8 here. Awesome. All right, let's keep going. And if you want to, I didn't want to draw out number lines for all of these on the board for you, but if you look on page 535, starting on that page in the book, it shows the number line movement, that representation of this same thing. So you can kind of look at what's happening on the number line as well whenever we're adding these positive and negative integers. So that might help you too if you're having a little trouble understanding like what I'm actually doing here. So please take a look at that and that may be helpful as well. So let's look at the next one. We're gonna try adding negative 6 plus positive 6. So same question, same signs are different. They are in fact different. Negative 6 and positive 6. Different means subtract. So we're gonna subtract 6 and 6, which gives me 0. Now here we're in a unique situation because 0 is neutral. The sign doesn't matter. So we don't even have to think about, well, was it supposed to be positive or negative? Because it doesn't matter. It's neutral. Okay, so we get to move on from there. Then we've got positive 6 plus negative 6. You might be saying, that looks like strangely familiar. It's pretty similar to the one before, something just a little bit different. We see that the order has been flip-flopped. Let's just think about this real quick. Does the order in which we add things matter? Does that change our result if we flip the order? It doesn't. And if we were in class, I would say, what property is that? And I know that somebody would remember and say commutative property, and I would say you are right. So the commutative property tells us that in addition and multiplication, the order doesn't matter. We can flip-flop the order all day long, and it's not going to change our result. Okay, so if negative 6 and positive 6 add together to give us 0, then positive 6 and negative 6 are going to do the same thing. They are going to add together to give us 0. And you could have done the same process. You could have said they are different signs, so we subtract them. 6 minus 6 is 0. You get to the same place. All right, awesome. Moving on. So now it kind of leads us into thinking about the opposite of a given number. So like we talked about in the very beginning when we looked at the number line, we talked about how integers are made up of whole numbers and they're opposites, okay? So just like that, though, a negative number can have a positive opposite. So if we are trying to find the opposite of negative 7, its opposite would be positive 7. Or the opposite of 10, its opposite would be negative 10. Okay, so a number's opposite is just its negative corresponding part, okay? So that's all that's asking. The reason that we're talking about that is because we're about to look at what happens whenever we're not given an addition problem, we're given a subtraction problem. So here's the deal. The rules for addition are going to still apply, but there's a step you have to complete first when it is a subtraction problem that's given, okay? So I'm going to show you what I mean. If you are given a subtraction problem, like negative 10 minus negative 6, okay? So far we've only looked at addition problems where this sign right here was a plus, okay? We can still use those addition rules as long as we turn this into an addition problem. And you might be thinking, what? I do not have magical powers. I cannot turn subtraction into addition. Well, guess what? You can, and I'm going to teach you how. But you have to follow the rules, okay? You can't just all of a sudden make this into an addition sign. It has to be done correctly, okay? So we can do that. We can turn it into an addition sign only if we also change the sign of the second value. Okay, so we can make this addition as long as we change. If this is negative, it's going to become positive. If this was positive, it would become negative. Okay, so everybody with me? So let's just kind of summarize what we just did real quick. So a subtraction problem can become an addition problem by two things. Number one, changing the minus to a plus, and then also both of these things have to happen together, okay? You can't just do one of them. Also changing the sign of the second number, okay? So you might want to stop and pause and write that down too in your notes, because this is also something that is talked about, but maybe not in these exact words in the book. So it might be helpful for you to just have this written down so you can go back and look at it as you go. So you can pause here and then pick right back up. Okay, so let's look at a couple more examples. So let's do that one again, just so you can see it all the way through. So like I said, if it's a subtraction problem, you can convert it into an addition problem so that you can use those same rules we've been doing. Okay, so this would become plus, but you can only do it as long as you also change the sign of the second term. So now we are looking at an addition problem, so we can use the same rules. Are these the same signs or different? They are different. So we can subtract the values, which 10 minus 6 gives me 4. But remember, to find the sign, the rule is when you subtract, you take the sign of the bigger number. 10 is bigger than 6. And the 10 is negative. So my answer is going to be -4. Okay? All right, so let's look at another one. If we've got -3 minus +5. Okay, again, minus, we can only use our rules with addition, so we have to turn this into an addition problem. So we can make this a plus, but if we do that, we have to change the sign of this one, which means making it negative, okay? Because it was positive, so now it's negative. Now we can do our addition rules. Same signs are different. They are the same. So we add, which gives us 8, and our rule is to keep the sign. So if both terms were negative, our result is also going to be negative. Okay? So I would definitely go ahead and practice these, and either do just the practice or go ahead and do your homework while it's fresh on your mind. And then it's going to keep coming back. So don't just think you can just you guys know that, but we can't just let it go. You got to keep working on it, got to keep practicing it so that it stays really strong and sharp. And we'll definitely be working on these in the warm-ups, because like I said, this is just one of those things that students just have a hard time with. You just got to know these rules. You got to feel comfortable with the process so that you don't get mixed up with the signs. Okay. But you guys got it. I know you can do it. All right. Happy 100th lesson again. So close to the end. I'm so proud of you guys. Hang in there. Okay. Keep up the good work, and I look forward to seeing you again in our next meeting. Bye-bye.